Electric cars certainly reduce your carbon footprint, but making lithium-ion batteries could emit 74% more CO2 or carbon dioxide than conventional cars. What if there was a cheaper, more environmentally friendly battery technology that didn't use any metals? A startup, Polyjoule, has come up with a new breakthrough type of battery made entirely from good old plastic.
We've got a technology that will meet all the criteria of the grid, and on top of that, it's easier to deploy.
So why would anyone want to use a plastic battery? And given the intermittent nature of renewable energy, battery storage is a critical link in the renewable power system. Among the many technologies that are emerging in the domain, Boston-based Polyjoule, a spin-off of the Massachusetts Institute of Technology, has created a battery that uses electrodes made of conductive polymers. Polyjoule? Polymers? Anyway, these are plastic-like, non-metal, organic compounds that function as metals for the purposes of charging and discharging energy in a battery. Polyjoule outlined their approach that
we do everything throwing out the rules of existing lithium-ion batteries.
So, want to know how this battery charging time compares to the 4680 lithium-ion battery? Polyjoule also claims its polymer battery outperforms lithium-ion across the spectrum. With approximately 12,000 charge cycles, this battery outperforms the 4680 battery by 600%. In contrast, a 4680 battery might manage only around 2,000 to 3,000 charge cycles in its lifetime. Polyjoule batteries are also able to discharge around 1 megawatt of power in 10 seconds compared to the 60 seconds an average lithium-ion battery needs. The team also suggests a Polyjoule can be charged in under 5 minutes, which is 7 times faster than the 4680 battery cells. Because the 4680 batteries would require around 32 minutes or so to reach a level of charge of 80%. Moreover, we all know that 4680 batteries have lifespans of around 25 years, but Polyjoule claims that their technology could nearly double that, with a projected lifespan of 50. Moreover, its lifespan is almost 3 times longer than GM's Ultium battery. In real-world use, an Ultium battery will last around 150 to 250,000 miles, which is equivalent to 11 to 18 years. But another important area that we need to discuss is, obviously, the expense. How much is this Polyjoule battery going to run you? Experts suggest that for batteries to be useful in renewable energy storage, their price needs to be reduced to around $20 US. Polyjoule is not quite at that point yet. The team claims their batteries function at around $65 per kilowatt hour. In contrast, although lithium-ion batteries have reduced drastically in price in the last decade, they still average around $132 per kilowatt hour. A Polyjoule battery is also 1.5 times less expensive than an Ultium battery, which is priced at $100 per kilowatt hour. But what about the manufacturing process for this type of battery? Is it easy, and is it safe for the environment?
So we start with the periodic table of organic elements.
Since they are constructed entirely of polymer, Polyjoule batteries do not contain minerals such as lithium or cobalt, which must be extracted and refined before use. Their water-based manufacturing chemistry can be produced using already commercially available equipment and does not require clean room conditions. To prove the ease of production, the startup has already produced over 10,000 Polyjoule batteries using simple roll-to-roll processing.
Based on 10,000 trials, that makes a very good battery for the home that meets that criteria. Low cost, safe, and a long lifetime.
Price prediction can reach $30 per kilowatt hour in 2025. But one aspect that many people are interested in is the level of safety, because there are many battery fires happening in this day and age. So, how about this battery?
polyjoule batteries can actually deliver the high power peaks over shorter durations without sacrificing.
The polyjoule is described as ultra safe, and unlike lithium-ion batteries, it will not become warped or disfigured with overuse. Having an inherently safer chemistry allows polyjoule to save on system integration costs, among other things. Polyjoule batteries don't contain flammable solvents, which means no added expenses related to fire mitigation. Safer chemistry also means ease of storage, and polyjoule batteries are currently undergoing global safety certification, UL approval, to be allowed indoors and on airplanes. Finally, with high power built into the chemistry, polyjoule's cells can be charged and discharged to extremes without the need for heating or cooling systems. Moreover, according to the company, their batteries are 95% recyclable because it's polymer-based, and they use organic materials instead of bulk metals to form a battery. Using polymers for these types of batteries could create a whole new market for recyclable materials, which could be major. Plastics could be put into the batteries, so at the end of their lives, they're recyclable. Besides the great advantages, this battery has some roadblocks ahead, and now let's talk about them. A polyjoule battery cell under development has an energy density 5 times smaller than 4680, or about 60 watt-hours per kilogram. This means polyjoule would need a battery 5 times as big to store the same amount of energy, making it not ideal for your phone, laptop, electric vehicles, or other applications where size is an important consideration. Each power string measures 2.2 meters by 0.8 meter by 3.4 meters and weighs 1,590 kilograms. Its nominal voltage is 528 volts, and the voltage range is 158 to 972. The manufacturer ensures continuous operation at temperatures between -40 to 50 degrees Celsius with minimal capacity loss. Polyjoule is directing their batteries largely towards static applications, such as air conditioners and heaters, industrial energy storage, and data centers. In particular, they suggest their batteries will be particularly useful in situations where a lot of energy is needed quickly, such as in critical infrastructure and renewable energy management. Today's conventional lithium-ion grid-scale battery storage facilities like Tesla's Powerwall and PowerPack can typically supply electricity to the grid for about 4 hours. They're also optimized for regular daily use. Charge up during the day when the sun is shining or the wind is blowing, then discharge in the late afternoon and early evening when the demand for electricity spikes. They aren't really designed to store electricity for days, weeks, or months. However, polyjoule's plastic batteries might be able to store energy for longer, at about 20 hours. It's an impressive time. They're also figuring out if the polyjoule batteries can store seasonal energy to balance the grid. Battery storage is always speculative. The transition from laboratory to commercialization is fraught with danger. However, by the end of the year, polyjoule will have delivered its first 10 kilowatt-hour system, exiting stealth mode and adding commercial viability to its demonstrated technological superiority.
Lead to the commercialization of sodium-ion batteries as soon as the cost of lithium-ion batteries will increase again.
The cost of lithium has risen from $4,450 per ton in 2012 to $78,032 in 2022. That's an increase of 1,654% in the past decade and a 480% increase in just the past year. Now, what if a new battery costs only about $15.15 per kilowatt hour compared to the $101 per kilowatt hour price of a lithium-based battery? This is exactly the exciting battery innovation that CALT has to offer. So what makes the cost of this groundbreaking battery so low? What other advantages come with it? Battery technology is moving so fast that sometimes it's hard to keep up. That being said, CATL has set up a large supply chain for the batteries and has entered negotiations conversations with some car makers about the possibilities of sodium-ion battery use. Sodium-ion technology is ready, cheap, and safe, but can it oust lithium-ion? Elon Musk tweeted that the price of lithium has gone to insane levels. So how then does the price of a sodium-ion battery compare? The absolute advantage of sodium-ion is the low cost. Sodium is 2.3% of the world's crust. It's over 1,000 times more abundant than lithium. From the perspective of raw materials for anodes, the recent price of lithium carbonate is $570,000 per ton, while the price of sodium carbonate is less than $3,000 per ton. This means it is 190 times cheaper than a lithium-ion battery. CALT even said that sodium has better conductivity and that the concentration of the electrolyte can be reduced, which also reduces the cost by about 85%.
And they're more common, easily found, cheaper. Those are the advantages.
The average price of a Tesla 4680 battery pack will be $101 per kilowatt hour in 2022. We can then use this to calculate the new battery costs, which is roughly at $15.15 per kilowatt hour, or nearly 7 times less than the 4680 battery. Thus, if you own a Tesla Model 3 standard range with an estimated battery capacity of 50 kilowatt hours, instead of having to pay $5,050 for a revolutionary game-changing battery, the cost is really low. But then how far can the sodium-ion battery actually go? Its applications in passenger cars have shown that it generally meets the needs of models with a range of up to 248 miles. Through pioneering its AB battery system integration technology, CATL has achieved a mix of sodium-ion and lithium-ion, allowing them to complement each other and thus increase the energy density of the battery system. This approach allows sodium-ion batteries to be able to support EV models with a range of up to 310 miles, while the 4680 Model Y has only a 279-mile range. But charging time is what most electric vehicles often care about. So how long would it take to charge a sodium-ion battery? CATL's sodium-ion cells can charge in 15 minutes to 80% at room temperature. For comparison, with fast charging at a public station, a Model Y from Tesla recharged from 0 to 80% in 32 minutes, which is over 2 times longer than the sodium-ion battery. Now, how well does sodium-ion perform in freezing temperatures? Lithium-ion batteries can only function optimally at 15 degrees to 35 degrees Celsius, which is why they are problematic in the wintertime. CATL's sodium-ion battery will sustain a 90% capacity retention rate at negative 20 degrees Celsius and still has a retention rate of more than 70% at negative 40 degrees Celsius. In winter, the problem of electric vehicles' inability to cruise will no longer be apparent. Also, we haven't seen anything that says there is a significant degradation at higher temperatures either. Now, how safe are sodium-ion batteries actually? The sodium-ion battery has similar working principles to the lithium-ion battery. Sodium ions also shuttle between the cathode and anode. However, compared to lithium ions, sodium ions have a larger volume, as well as higher requirements in terms of structural stability and kinetic properties. This has become a bottleneck for the industrialization of sodium-ion batteries. Sodium-ion batteries are safer because they are less flammable than lithium-ion batteries. Newly developed sodium-ion technology uses a naturally fire-extinguishing solution that is also impervious to temperature changes and can operate at high voltages. One key to this feature is the ultra-thin protective layer that forms on the anode. This ultra-thin layer remains stable once formed, providing the long cycle life reported in the research article. Despite making significant breakthroughs, the chemical composition of lithium metal batteries has always posed a lot of challenges. What are they exactly?
Now, I understand that sodium-ion batteries have a lower energy density than lithium-ion.
The biggest downside is that sodium-ion batteries have a lower energy density than lithium-ion batteries. This means an EV with a sodium battery that's the same size as a standard lithium-ion battery would not be able to travel as far on a single charge. CATL's first-generation sodium battery generates 160 watt-hours of electricity next to a mainstream lithium battery. Last year, CATL unveiled its first sodium battery prototype and said it's been focusing on developing developing new technologies for a second-generation sodium battery that can generate 200 watt-hours per kilogram. In contrast, mainstream lithium-ion batteries have 200 to 300 watt-hours per kilogram. Although their lower energy density is improving constantly, the first generation of sodium-ion batteries is better than lithium-ion cells from 6 or 7 years ago. How about real-life applications?
Makes a difference in the kind of applications in which they're used.
The first generation of sodium-ion batteries can be used in various transportation electrification scenarios, especially in regions with extremely low temperatures where their outstanding advantages become obvious. Also, it can be flexibly adapted to the application needs of all scenarios in the energy storage field. We now see that various new batteries are being investigated in the lab, but it oftentimes takes them 5 or even 10 years to reach market. Or will they be released soon?
US and China, and also a large battery company, CATL, recently announced that they will go on production actually in 2023.
Even so, sodium-ion batteries will eventually become the mainstream choice. Lithium-ion batteries will be most likely used in upmarket vehicles, but for everyday use, we don't need the expensive lithium. This is as much of a revolution as the electric car itself, as we have finally found a cheaper and more viable battery option. Tesla has estimated that there are 5 lithium battery fires for every billion miles traveled, compared to 55 fires per billion miles traveled in gasoline cars. However, it can take up to 24 hours for a battery fire to be fully extinguished. To solve this, LG Chem has developed new breakthrough materials that have the longest flame-blocking duration. So why wouldn't anyone want this material? And how effective is it exactly? LG Chem said it had developed a highly heat-resistant plastic that can significantly delay thermal runaway in the 4680 batteries used in Tesla's electric vehicles. LG said the new material has the longest flame-blocking duration in the world. But what kind of plastic? LG Chem's new flame-retardant material is described as a highly functional engineering plastic comprising various material groups, including polyphenylene oxide, polyamide, and polybutylene terephthalate. Compared with other flame-retardant plastics, the materials can block heat for longer periods of time when it is applied to the electric vehicle's battery pack cover. But then how much does this plastic material from LG Chem cost? According to LG, the cost of the material is only 20% of a Tesla's 4680 battery pack. Tesla charges $7,400 for a Model Y 4680 pack. Therefore, installing this extra material only costs around $1,500. If you don't want a fire in your car, this expense is insignificant. Now, how exactly does it help? LG Chem said in-house tests showed the material prevented flame propagation for over 400 seconds above 1,000 degrees, 45 times longer than general flame-retardant plastics, which would provide more time for the safe evacuation of vehicle occupants in the case of a battery fire. The material is also said to have superb dimensional stability, maintaining its shape despite extreme temperature changes. LG Chem said thermal runaway is a main cause of fire in electric vehicle batteries, which occurs when battery cells suffer stresses from various sources, causing overvoltage and over-discharge short circuits. Fires start once the cell's internal temperature rises above a certain level. Lithium-ion batteries are also highly reactive to water, meaning that fires are hard to extinguish with water. Last year, several EV fires in the US which caused severe injury were found to have been caused by defective LGES batteries. But speaking of the flame-blocking duration, how about the longevity of this material? How many years will it last? This product is expected to last 50 years because it's made of durable materials, unless your car unfortunately catches fire, in which you'll then have to replace the cover. I've gotta say, there's many advantages to having this cover. So when are we going to see this material in the real world? LG Chem intends to begin commercial production next year and work on patent applications for the new material in South Korea, the United States, and Europe is already underway, according to the company. For Tesla, the 4680 batteries are an essential component. How then is manufacturing of the Tesla 4680 battery coming along? Tesla announced this week that The Cato Road pilot battery facility in Fremont, California, achieved a new production milestone. According to the company's tweet, the team managed to produce roughly 868,000 4680 type cylindrical lithium-ion battery cells during the last week. That's about 124,000 cells produced every day. A Twitter user, Alex, has made a production ramp forecast for the 4680 batteries. He expects a run rate of 4 million cells per month in mid-January of 2023. The current run rate is about 3,840,000 per month. Previously, this facility produced a cumulative number of 1,04680 type cells in February since the production started in 2020. We don't know what the current cumulative number is, but with 10 months now down the road, it should be more than 10 million units. With current production, how many Model Ys will be produced? We now see that 868,000 4680 battery cells are enough to produce over 1,000 Model Y vehicles. Annualized, that's 52,000 cars a year with 4680 batteries. The cells are used to produce one type of Model Y vehicle with a structural battery pack at Gigafactory, Texas. Tesla is definitely on an exponential trend, and these 4680 batteries will be used in the Tesla Semi, the Cybertruck, and possibly the Model 3 with LFP batteries, but that remains to be seen. But what are Tesla's competitors doing to ramp up battery production? This is from German luxury car maker BMW, which has shown off its latest electric car technology. But the company has all but admitted to copying Tesla's work. So the question has to be asked, can BMW take on Musk? BMW's new battery is known as the Gen 6, and it is a complete departure from any battery design they've used before. The Gen 6 is a large cylindrical battery, 46mm wide and either 95mm or 120mm tall. For comparison, Tesla's cell is slightly smaller at 46mm by 80. So what then is the result of all of this innovation in the BMW battery? Well, BMW can get 30% more range from these packs, allowing them to build EVs with over 620 miles of range. The Tesla Model Y all-wheel drive is equipped with 4680 type batteries, rated at 279 miles of range, which is 341 miles less than the BMW battery. The Gen 6's weight also goes down by up to 30% thanks to the increased energy density. The new internal chemistry and better cooling allows charge speeds of 270 kilowatts, making 10 to 80% charge times as short as 15 minutes. In contrast, charging a Model Y equipped with the new battery at the latest V3 supercharger attained a maximum charging power of 250 kilowatts and took 32 minutes to charge from 0 to 80%. It looks like BMW's new battery is making big breakthroughs. Moreover, BMW is bringing in a third-party manufacturer to get production started, which may get these batteries into their cars by 2025. So does this spell out the end of Tesla's EV dominance? Musk has several options. First, he could pile more money onto the 4680 development and ramp production up to scale more quickly. Tesla does have the cash reserves to be able to do this as well. After all, I'm sure BMW wouldn't mind getting a licensing fee for this battery, and Tesla already uses CATL to supply their 2170 batteries. Either way, it seems Tesla has always been ahead. It's taken BMW many years to catch up to Tesla.
So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster.
Elon Musk added, "I believe that one day in the future we will develop a super fast charging electric vehicle battery, opening a new era for the electric vehicle battery industry." In the past, the Tesla CEO has always been looking for a way to have a battery for Tesla electric cars that can charge very quickly, hoping to one day have a charging time that's even faster than fueling up at the gas pump. That is about to become a reality, as recently scientists have developed a type of battery that can charge in just 1 minute. So what battery is it? And will it replace the 4680 batteries? A research team at the Korea Advanced Institute of Science and Technology, or KAIST, has developed a high energy density, ultra-fast, rechargeable hybrid lithium-ion battery that can be used in smart electronic devices and EVs. Also, according to the scientists on the research team, the new hybrid lithium-ion battery cells are claimed to deliver far more power density than current lithium-ion batteries, without the cooling and heating problems that normally would be apparent. Accordingly, it can be rapidly charged with a high power density of 22,600 watts per kilogram, which is expected to overcome the limitations of the current energy storage system, which will truly be a breakthrough. So, a battery pack weighing 1,000 pounds could achieve a battery charging rate of 22 megawatts. That would charge a vehicle 220 times faster than current charge sessions if there's a way to deliver that much power to the vehicle somehow. So yes, you'd definitely be done with electric vehicle charging in under a minute. The research team synthesized a porous carbon hollow structure with a large surface area by changing the orientation of the polymer resin from linear to twisted. When the twisted resin was carbonized, more micropores were formed, and a carbon structure with a surface area 12 times larger than that of the conventional linear resin was created. The carbon structure created through this process was used as a capacitor-type cathode material. In addition, the anode was made using a germanium-embedded hollow carbon nanosphere material to reduce degradation and maximize the dispersion of lithium ions. The researchers found that the hybrid lithium-ion batteries using those special electrodes had an energy density which is higher than that of conventional lithium-ion batteries, and the power density characteristics of a capacitor, allowing for recharge within a minute. They also claimed that so far there are no temperature problems. 25% of a lithium-ion battery pack in a vehicle is to do with cooling them. There is a very high chance that we won't need that cooling or heating at all. One advantage that makes this new hybrid lithium-ion battery more competitive than conventional lithium-ion batteries is the cost of production. According to some sources, the price of each hybrid lithium-ion battery charging in 1 minute is only around $5.21. Meanwhile, the price of a Tesla 4680 battery is at about $11. So the cost of each hybrid lithium battery is much cheaper than that of the 4680. Researchers at the Massachusetts Institute of Technology said that research and development, particularly in chemistry and materials science, has been the major factor in dropping the price of the hybrid lithium-ion battery. The group examined data from a wide variety of sources, reaching the conclusion that improvements to the technology through research and development have been responsible for at least 50% of the price reductions achieved so far. Dr. Micah S. Ziegler at the Institute for Data Systems and Society at MIT, a member of the researcher team, also analyzes that efforts to increase cell charge densities made a 38% contribution to the overall cost reductions of battery, while work to reduce the cost of cathode materials made up 18%, and reductions in non-materials costs constituted 14%. Not only that, the lifespan of the hybrid lithium-ion battery charging in 1 minute can be up to around 80 years, which is similar to 1.2 million miles capable. Meanwhile, the life of 4680 Tesla battery cells is designed to be used for 20 to 30 years. Thus, the lifespan of this ultra-fast charging battery is about 2.7 times as high as the lifespan of the Tesla 4680 battery. So, when will this ultra-fast charging hybrid lithium-ion battery officially be put into mass production? Currently, the scientists over at KAIST say that they are only in the early stages of research and development of this battery, hence it will still take a few more years to officially bring it to the market. On top of that, has any manufacturer produced a 1-minute rechargeable battery yet? Previously, an electric vehicle startup, Fisker, announced a battery that charges very quickly in just 1 minute. But after that, Fisker said that it had given up on solid-state batteries after having announced a breakthrough that was supposed to enable 500 miles of range and 1-minute charging in its electric cars. Fisker believes that the technology is nowhere near ready for commercialization. In the meantime, other battery manufacturers with scientists have also moved one step closer to producing super-fast batteries. Accordingly, researchers from the University of Queensland and the Australian Graphene Manufacturing Group, or GMG, have presented a new graphene aluminum-ion battery that is supposed to charge 60 times faster than current lithium-ion batteries in only 10 seconds, and is a more sustainable battery prototype with a lifespan 3 times the length of current lithium-ion batteries, with an estimated lifetime of 3,000 charge/discharge cycles. Meanwhile, a typical lithium-ion battery lasts about 1,000 cycles. Additionally, StoreDot, the pioneer of extreme fast charging, or XFC, battery technology for electric vehicles, has revealed its strategic technology roadmap, labeled 100 in X, which will deliver batteries capable of charging 100 miles of range on just a 2-minute charge, with mass production readiness planned within 10 years. StoreDot is also firmly on track for its first milestone for global automotive manufacturers, which include producing its silicon-dominant anode XFC lithium-ion cells at scale by 2024 that will be capable of delivering 100 miles of range in 5 minutes of charge. And most recently, the Israeli startup has successfully demonstrated its 105 extreme fast charging battery technology, publicly charging a full-scale EV battery pouch cell with enough energy in 5 minutes for 100 miles of range. The demonstration featured a 300 by 100 millimeter pouch cell produced at EVE Energy's manufacturing plant in China. The battery was charged under a 10-minute time limit, during which the cell charged to 20 ampere hours, or amp hours, exceeding the 0% to 80% capacity target set for the demonstration. Furthermore, an extreme fast charging battery tech developed by the Israeli startup got one step closer to commercial viability with an investment from Volvo Cars Tech Fund, the Swedish carmaker's venture capital arm. That's it for today's episode. We sincerely thank you for watching and for all of your support of our channel. And as always, if you enjoyed our video, please leave a like, share the video, subscribe to the channel, and ring that bell to stay up to date on exciting developments in the world of EVs. And please be sure to leave a comment down below to tell us what you thought about today's content. Once again, we thank you so much from all of us here. We hope to see you again next time. Until then, take care and be safe.